I was saying that this screen recorder I'm using can allow only 10 minutes per recording. Anyways, basically communication in computer, the process is simple. The user inputs. Now that we explained some of the components of a computer, we now know that a user, this is how it works. A user inputs an instruction from outside using an input device, which can be a keyboard, which can be a mouse. For example, you click on a mouse, you are sending an instruction to the computer to do something. You press on the keyboard, you are sending an instruction to the computer to do something. The computer, being an electronic device, right, is able to understand this thing, and how it works is that this instruction leaves this particular keyboard from that particular point and is transmitted through buses. And buses are the, in if you're in normal wiring, I mean in normal electricity, I mean electronics, not electronics, in normal circuitry, you use wires to transmit electricity. But in a computer board, in electronic boards, circuit boards, they use buses. They call it buses, and they are just conductive pathways. They are where current flows through, right? So through those buses, these instructions can leave the input device to the memory, and then from the memory there is a whole lot to it. This is a very simplified version I'm explaining to you. From the memory, the instruction are going to be sent to the processor. There is something called the control unit, just like we talked about the arithmetic unit. And then there are also things called registers. There are instruction registers. There are a lot of registers. I don't want to start talking about them, right? But anyways, the specific instruction that's going to be needed for processing is going to be sent from the memory now to the CPU. And this movement, they are all going through buses, and there are priority levels that are going to be assigned to each of the instructions though. But the computer processes the instruction based on the one it receives, following their priority level. When it is processed, it can be sent back again. Now, this, after processing, this information can be stored, or it can be sent back to the user as feedback. If it's going to be stored, then it's going to be stored in, let's say, the secondary storage, for example. And if it's going to be given back as feedback, it's going to be sent to a display or an output device that can be either a monitor, like your desktop screen or your laptop screen, or maybe like the speaker, or maybe the printer, where any of those output devices where the process information can be returned. And then that's an oversimplified version of how this particular process works. Now, if you are very interested in that, you want to have a conversation around it, I'm very, very free, and I'll be more than willing to do that. So you can just send a message, and I believe all of us here have access to me personally, so we could discuss better on that, right? So this is how it works generally. And the communication cycle starts from the fetch, decode, execute, and store. It's very easy to understand. The fetch is when the CPU retrieves the information from the memory. Like I said, the instruction you send is stored in the memory sends it to the CPU. So that's the fetch. That's the level 1. Level 2 is decode. Is when the control unit tries to understand what instruction the user sends. And then the execute is the logic unit in the system unit, in the processor, trying to carry out that operation. If the operation is a 1+1 operation, it carries it out. If it's music it wants to play, whatever it is that you want to do, right, that instruction is being done, is being executed, and the results are either stored or they are sent to you, like we explained in the previous slide. So this is the communication cycle. Again, this is an oversimplified version. There's a lot to it. So this is an example using using a printing process. I've explained that in the previous, right? So yeah, there are some components in your computer that you can replace without without using some specialized tools. I mean, you cannot just readily remove your BIOS. You cannot. There are some parts of the computer that you cannot really remove, but the ones that you can easily change, like your hard drive, your battery, your RAM, without having special tools, they are called field replaceable units. So you can easily shut down your PC and open the cover and just remove your RAM if you want to upgrade your RAM to a higher one, right? If you want to like change your battery, you just shut your PC down and remove the battery and put another one. You want to change your graphic card, you don't need any specialized tool in order to do that. So that's just field replaceable components. So we say that just for you to know, those of us that don't know, you're not aware that yeah, you too can change your RAM by yourself, you can change your hard drive by yourself, you can change your battery by yourself, like that. But if it's a desktop computer, I don't advise you work. It's also a field replaceable component. It's a replaceable unit, but I don't advise you tamper so much with your power supply unit in your desktop computer if you don't have the expertise, but it falls into that category. So all you need to do is just put off a PC and open the casing. You remove what you want to remove and replace it with the one that you want to remove. But you do make sure your PC is completely shut down before you do any of that, right? So we've explained this input output addresses. I'm going to skip this part for now because we're running out of time, and because it's going to be a little bit more technical. But in the system organization and architecture, we explain in terms of how the CPU process the data. This is just what it means, right? You can make reference to those materials to understand them. And I mentioned very briefly about DMAs, direct memory accesses, and then we also talked about input and output devices. Well, we talked about registers, and we said we don't want to talk about them, but yeah, there are addresses that are allocated to instructions and like that. So we'll not be going deep into that for now. So we'll move straight to the next slide. Our time is almost up. Troubleshooting basics. You have to troubleshoot basically, identify what the problem is. This is important because as a cybersecurity guy, even though you are not an IT administrator, basically what you'll be doing is looking for problems and trying to stop the problems, or trying to take the probable cause of a problem, or when you have a virus attack, or when you have when your system has been compromised, you're trying to look for where the problem is or how the attacker did that. You're basically going to be using a lot of troubleshooting skills like that. But in the most basic level, it all starts by finding problems and finding fixes to those problems as much as possible. And usually it's done by trying very, very different possible options that are related with the particular symptoms that you're seeing until the problem is found, right? The way you do that, to document it, and next time when that issue occurs, next time you know that this is how you go about it. So troubleshooting basically just means trying to find problem with your PC or your network or any of the IT device that you're working with. So we are going to go to networking next. This is a very basic level, but we're not going to do that right now. We're going to stop our session right now. By tomorrow we'll finish the rest and begin to prepare for cybersecurity introduction properly. So if there's any question that you have, feel free to drop them in the group. We are going to create a system properly for easy access to these videos. I'm very, very sure that you're not very comfortable as you're doing it short like this, but for now this is the best that we can get. So thank you all so much for today, and I hope the session was impactful. Feel free to ask any question you have. I'll be more than willing to answer, and if you don't understand any concept, I can explain better again personally for you. Thank you so much.